Assalamualaikum warahmatullahi wabarakatuh. This video is about integrated design project 3-phase AC motor starters by Group 26. As you can see, there's 3 group members. From the left, Muhammad Izzat bin Jamil from Programmable Logic Control course, Muhammad Danial bin Elias Electrical Power Laboratory and Programmable Logic Control courses, and me, Muhammad Fitri Najmi bin Mohd Farid from Electrical Power Laboratory course. So this is what we obtained, the objective, before doing the report. To develop skills operating the PLC on the fundamentals of power system and motor control starter components. To solve the engineering problems on program, testing, and troubleshooting the error in PLC programming. To domain knowledge and conducting the experiment on several types of starting electrical machines, power systems components, and the behavior based on calculation and theoretical. As you know, our main project is forward reverse. So for the case 1 and case 2, without PLC, we are successfully built and read with lecturer consent. For case 3, with PLC, are also successfully built and with lecture consent. Thank you.
Warahmatullahi wabarakatuh. My name is Muhammad Danial Elias and my matric number is DN210110, and I want to present about experiment setup for with label for case study 1 and case study 2. Okay, now I for case study 1, which is task 1, which is control circuit. Control circuit of forward reverse motor starter is using single phase connection from supply, which is consists of MCB. As we can see, for at the left side is our board connection, which is we have MCB component, forward contactor, reverse contactor, we have thermal overload relay, and then for controlling part we use 3 push button, which is the first one is forward push button, second one is stop push button, and the last one is reverse push button. And also for the signal part, it consists of 3 also, which is first is forward lamp L1, and then stop lamp L2, and reverse lamp L3. And this is the right at the right side is the control circuit diagram for our IDP project. So this is the experiment setup for with label for our control circuit. Next is for case study 1 also, but for the motor diagram. Okay, for motor diagram, forward reverse motor circuit is using 3-phase connection from supply, where current from supply will flow to the 3-phase main phase, which is used for circuit protection, same as MCB, and MCB will break if the current flow exceeds the limit. So 3-phase connection then will connect to the 3-phase input of both contactor, forward and reverse, for red wire, S for yellow wire, and T for blue wire. Output wire from forward contactor UVW will connected directly to the input 3-phase of terminal overload relay, as we can see here. The output for forward contactor UVW is connected directly to the thermal overload relay as RSTU, while for reverse contactor, the connection is a little bit different because we need to change the connection between U and V for the output reverse, where U output we connected to the yellow, which is S for thermal overload relay, and then for V we connected to the R thermal overload relay, and the blue connection will remain the same. So that is the difference between reverse and forward connection for the contactor in the motor 3-phase diagram. Whereas for the reverse, we change the connection because we want the motor to rotate in the opposite direction from the other contactor. And as you can see, for the experiment setup, we have also same as control circuit, but you can see here we use 3-phase supply, so we need to use 3-phase wire, which is red, yellow, and blue. So here main switch, three-phase main switch. We use three-phase main switch, forward contactor, reverse contactor, three control part, which is forward push button, stop push button, and reverse push button. And then we also use three signal part, which is forward lamp, stop lamp, and reverse lamp, same as a control circuit, but we use main switch different as MCB as control circuit because we use three phase current. So next I want to explain about case study 2, which is forward reverse motor starter with PLC. Okay, for setup with PLC, all component is the same as without PLC, but we need to add two more relay, which one relay for forward and another for reverse. Then we use PLC. As we can see here, all component is same as without PLC, where we have main switch, forward contactor, reverse contactor, and then we need to add relay forward and reverse relay, which is here. And then we use PLC CP1E for our PLC, and then we also have power supply for our PLC power supply. And then also same, we use push button forward, push button stop, push button reverse, and then we have forward lamp, stop lamp, and reverse lamp. The connection with PLC is a little bit different because for this case study, we have input, which is the controlling part, push button, and output part, which is contactor. Relay will be an intermediate control for each of our contactor because as I said, we have two relay, for one for forward and then one for reverse. So the right side is the connection diagram for our case study 2 with PLC. So that's all from me for experiment setup with level.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Izzat bin Jamil, and I will explain about the discussion and the conclusion of the IDP project. So, based on this project, students prefer to choose the PLC as the control system. The reason why students choose the PLC is because it has an advantage while doing this project. For example, the PLC is flexible and reliable, means that PLC is easy to bring anywhere. In this project, in task 3, we need to use a timer to move the motor in the forward and the reverse. So we don't need to bring any component of timer in the hardware, because in the PLC it has a timer function already. So while doing the construction system with the PLC, we face the two challenges. So when doing the combination of the three-phase circuit with the PLC, students have found the difficulty doing the connection on the PLC, relay, and all three push buttons. So to solve this problem, students need to reopen all the push button and check the connection as in the electrical wiring diagram. So lastly, students have found some problem when transferring the ladder diagram on the complete wiring with PLC. On the first trial transfer, we students see that the three push button and the output don't work as the instruction need. We using a shortcut on the keyboard. So we just do the shift W to transfer the ladder diagram. So to solve this problem, student need to retransfer the ladder diagram without using the shortcut keyboard. Means that we need to use one by one as the class PLC before taught us. So lastly, the conclusion. So in conclusion, students can develop the operating skill on the PLC fundamental of the power system and the motor control starter component. Also, students can solve the engineering problem on the programming, testing, troubleshooting the error on the PLC programming. And lastly, students can domain the knowledge on the conducting the experiment on several types of starting electrical machine, power system component, PLC function, and behavior based on the theoretical. So that's all from our group. Thank you for listening. So in the next video, we will show how our group doing all the three tasks in the IDP project. So thank you.
Okay, untuk permulaan, kita akan start MCB, turn on MCB, and then current akan mengalir melalui thermal overload relay, dan kemudian current akan mengalir melalui push button stop. Untuk sistem untuk stopkan sistem. Itu untuk cara sistem berfungsi. Apabila push button forward ditekan, lampu akan menyala sebagai petanda motor bergerak ke arah forward. Dan kemudian apabila interlock ditekan, motor reverse tak akan menyala. Lampu motor reverse tak akan menyala. Dan apabila tekan stop, sistem akan tutup. Dan apabila kita tekan reverse push button, motor akan bergerak dalam keadaan reverse dan lampu akan menyala. Apabila interlock push button forward ditekan, lampu tak akan padam dan lampu forward tidak menyala. Itu sistem.
Dia akan hidup dan kita akan mati. So, motor akan mati. So, motor akan hidup dengan reverse. Kita akan interlock. Motor akan stable juga. So, dia akan tak mati. Motor akan mati. Dah. Ini untuk question 1, forward reverse. So kita boleh sendiri, ini adalah input push button forward, push button reverse dan stop button. So ini adalah output untuk control contactor. Ini adalah relay untuk control contactor forward. Ini adalah relay reverse untuk control contactor reverse. Kat sini ni adalah diagram dia. Okay. So kita akan mulakan dengan start button. Start button, kita tengok kat sini. Kita akan tekan button latching, button interlock. Okay. So kita akan stop.
Motor akan stop. Reverse.
Sangat reverse. Motor akan pusing dengan reverse. Lampu akan menyala. Dan button interlock.
Assalamualaikum warahmatullahi wabarakatuh. Kami daripada grup 26 nak present tentang PLC activity 3 with timing. Okay, ni adalah control input lah. Consists of 3, which is push button start, forward, push button reverse and stop push button. This is the output of the activity, which is the relay akan connected with contactor. Relay 1 connected with contactor forward dan relay 2 connected with contactor reverse. Itu adalah untuk output dan input bagi aktiviti 3 atas bawah. Okey, untuk demo, bila push button forward ditekan, timer akan counting sehingga 5 second dan motor forward akan menyala. Lampu forward akan menyala dan motor akan bergerak dalam keadaan forward. Untuk interlock, apabila interlock reverse motor ditekan, motor reverse tak akan bergerak dan untuk berhentikan motor akan stop button. Okay. Untuk reverse motor, reverse push button ditekan, timer akan mengira hingga 5 second. Lampu akan menyala bagi reverse dan motor akan bergerak dalam putaran reverse. Interlock untuk forward,